Just waiting for that connection to come through. It sounds like my audio is only coming through like on a stereo channel, but it's a mono. Should be mono. Let me see if I can change that. Properties. Down next to mono. There we go. Okay, let me see if that fixed the audio thing real quick. Yep, that did it. Cool. It's kind of trippy. Watching myself back in time. Alright. So, we're still in this EDH2 journal. Because I created this data frame yesterday. Well, I already had it created yesterday, but so I have like some categorical variables and I have some continuous variables, and the categorical variables you have to one-hot encode, and if you don't know what one-hot encoding is, you can ask in the chat and I'll let you know. Which reminds me, I should type here. I check the chat about every 15 minutes. Thanks for joining. Let me spell joining correctly. Oh my god. I can write code, but I can't write English. There we go. Doot. Man, I wish there was like a... There's gotta be a way, I just don't know what it is to, I would like to hear like a ding or something whenever somebody leaves a message in the chat, so I don't have to like remember to check it. But anyway, so okay, I have some categorical variables, I have some continuous variables, and the categorical variables you have to one-hot encode, and so the problem I ran into was that pandas, when you one-hot encode something, pandas adds prefixes to the labels of those columns, so when you pass the data frame that's been one-hot encoded into something else like a linear regression model in stats models, it understands. I got mustache in my tongue. It's like stats models, like pandas will let stats models know that, hey, you have like, you know, half a dozen columns here, but they're all for the same variable, and you don't necessarily see that information when you look at the data frame, but it's there, and that information gets passed along from pandas to stats models, or at least that's my understanding of it. And so when I had this like nice data frame that I made where I cleaned up all the data and everything, dealt with like the nint values and the nans and all this stuff, and made it all nice, and I exported it as a CSV file so that I could use it in a different notebook, just so I wouldn't have like, you know, 80 cells um, in this one notebook. But that information about the one-hot encoding doesn't get passed along into a CSV file, which makes sense because a CSV file is basically a text file, right? It's just raw text that's separated by commas. Like, that's it. So you can think of it as just like one big long string. And so when you do use the read CSV function from pandas, all it's really doing is so in Python you have this, in vanilla Python you have a function called you use a string called .split. It's a method, sorry. So you call split onto any kind of string, and you pass in that method what you want to separate it by. And so when pandas does a read CSV file, it's basically just doing that as if you did called .split, and you just said split on the commas. Sometimes it's tabs and other things, and you can do all that, deal with all that in pandas. I'm going on a rant and I'm losing my train of thought. So it makes sense to me that the information that hey, these 6 columns are actually one variable. The fact that that information wouldn't be interpolated into a CSV file made sense to me once I ran into that issue. So, what I did was I went ahead and I made this data frame that is all of the one-hot encoded variables. So floors, condition, grade, bedrooms, bathrooms. And you can see here you pass in this prefix, and that's what helps pandas know everything with this prefix actually goes with that's not correct. Now it is. Goes with this variable, if you will. Man, there's variables for statistics and there's variables for coding, and sometimes I get mixed up on what I'm talking about. Good thing I caught that though. Dude, I thought I could have sworn I fixed this. Okay, this should be bed cats, this should be bath cats. So bedroom categories, bathroom categories. Grade cats, con cats, floor cats. Okay, cool. So all of these are getting concatenated together into one data frame called hot cats. And so that's just going to be one big data frame with all our one hot encoded variables. So yeah, and then so and then I concatenate hot cats with X. So I actually don't need all these. Originally I didn't have it all in hot cats. I just had the 4 individuals. But now I should be able to do hot cats. So that'll concatenate together the original cleaned data frame with all my predictors and then it'll concatenate that with the one hot encoded predictors, and then it's just dropping the original predictors since I don't need the original column because they've been one hot encoded over here. So I don't want duplicitous data that would cause multi-collinearity. I don't need that right now. So as you can see, the kernel's been, there's no kernel running right now. And I'm just checking to see any more typos or anything weird like that. I just found one. This notebook is not ridiculously long, but what is this about? Breakpoint. line list. That's very weird. Whoops. Come on, man. There we go. Okay. And I'll explain what this is here in a second. But first, I want to run everything above this cell. And that's going to take a second. The stream's current bit rate is higher than the recommended bit rate. We recommend that you stream at a bit rate of 1,000 kilobytes per second. I have no problem with that. I just don't know how to do it. Let me check Streamlabs real quick. You cannot change these settings when you're live. That's fair. Okay. So next time. Next time. Man, I would love to play some music right now, but I don't know how YouTube's gonna feel about whatever music I might play. Which is not optimal. Yeah. YouTube keeps telling me I have all these like things wrong with like my stream quality, but the connection's good at least. So we're just gonna roll with it for now. Okay, cool. Yeah, I went ahead and ran this Jark Barra test here. I didn't really need to necessarily, because you get that here, but it's good to see that I'm getting, I believe, the same score doing it manually versus using the stats model API. Right here. Yeah, so our kurtosis is absolutely massive. Like the standard normal distribution is like 3, and we have basically 10 times that right now. So that means that instead of having like a bell curve shape, I think that means that it's probably still got a hump, but it's very fat. Maybe almost like a triangle and not a bell curve. The skew, I believe you want to be as close to 1 as possible. But regardless, we have a heavy positive skew here, so that means that it means that we are left skewed. So our left tail is much longer than our right tail. That means that our mean is quite a ways away from the median, which is not ideal for a what's it called? Linear regression. The other thing that's suspicious is that all of our p-values are statistically significant, supposedly. So that means I'm either incredibly good at picking out predictor variables, which is not likely, or there's something very funky going on. The other thing is our Durbin-Watt score is nearly perfect. So like a perfect Durbin-Watt score would be 2. So Durbin-Watson's testing for homoscedasticity. So like, is your data really like spread and diffuse, or is it narrow and there's like an obvious kind of line going on? So that's weird, to say the least. But we'll take it. We do get some warnings or whatever here. Standard errors assume that the covariance matrix of the errors is correctly specified. Okay. I haven't looked at this. I haven't investigated the standard error a whole lot here. I hardly remember what the standard error. Well, I know what it is, but I'm not really sure how to interpret it here right now. That's pretty. I know that like the bigger this number is, the more unreliable the variable probably is. So anyway, we did our variance inflation factor. Like 3 of them were remotely acceptable. So like the level ratio, day of the year, and age are in an acceptable range. Everything else is so astronomical it's not even worth looking at right now. And then I did my root mean squared error and all that stuff. This is all basically just, these numbers are so huge that like they don't even really mean anything in particular other than like the data is just kind of like all over the place. We would like those numbers to be much smaller, to put it simply. Took some notes here, some observations on my initial linear regression. I'm going to transform the data, probably run another linear regression on it, and then create another data frame to go into EDA3. Cool. So you'll see here, we'll go ahead and check out this bad boy. I don't know why this is even down here. We should move that. Yeah, we'll put it here. Whoops. Damn. If I go here, yeah. I accidentally pressed copy again instead of paste and I lost it. There we go. Oh, this is gonna take a second, huh? There we go. Okay, so you'll notice here, we want this stuff to resemble a bell curve. And you'll notice that hardly any of it does, like at all. And I'm wondering what const is, what variable. Where is const declared at? Okay, so that's just the labels of all the stuff, because obviously you can't visualize on a histogram one hot encoded data. So this is everything that has not been one hot encoded. So it's all our continuous variables or features. So obviously, like none of this like is even close to a bell curve. Square foot of living, 15. Maybe level difference probably is the most standardly distributed. Day of year's not bad either, but this is all not really like good for a linear regression. So what we're gonna do is we're gonna log transform some of those variables, and that should scale the data so that it's closer to normally distributed. When we do that, we end up with a lot of nan values, which for pretty much everything, like especially like square foot and like relative living space and that sort of thing, those are meaningful zeros. And basically, NumPy is like seeing that zero and thinking that it's a nan value because it's zero. In this particular instance, those zeros are actually meaningful. So, like for example, for relative living space, this is square foot of living in relationship to square foot of living 15. Square foot of living 15 is the square footage of the 15 nearest houses to a given house. And so relative living space is an engineered feature that represents the difference there. So if the value in this column in any given row is 0, that means that house that row represents is the same square footage as the nearest 15 houses. So that's a meaningful 0. So we're replacing those nan values with zeros. This is I don't know if this is smart or good or whatever, but we're trying it. Basically, we get a lot of negative infinity values when we log transform, and it's way too much data for me to like feel comfortable just throwing it out. It's well over 5% of the total data. So what I did was I looked up like the maximum value for these specific features that had the nymph values, and I'm just replacing any nymphs with the negative of whatever the max value is. And so like the stats model still knows that like, you know, this value is the least like lowest number in the data set, but it's not negative infinity because you can't pass negative infinity into a stats model. So I should probably run this cell. Cool. And we're just going to declare those lists. And I'll show you here what's going on. So we're going to get some histograms of contlog, which is the log transformed version of everything you just saw above here a second ago. So this next visualization you're going to see is all this stuff, but now log transformed. And so you can see here like square foot basement had a bunch of nymph values. And so originally so this one and level ratio, I had it as like the negative and the maximum value, but there was just so much random space out here that it looked almost bimodal, and like that's not useful. So I just put it to like the very end. I put it in the outlier region of the distribution, basically. You'll notice that level difference and day of year, it actually kind of made it worse. So what we're going to do here, oh, that's why this cell was down there. Or I already have it, it's still on my clipboard. So we're going to run this cell now, and we're just going to replace those two features with the original data because it was more normal than the log transformed version. And we're going to wait very patiently for my dinosaur of a computer to, yeah, cool. And you'll see now that day of the year is back how it originally was, so is level difference. So everything here is still pretty jagged, but it is closer. It looks more normally distributed, at least, than before. So I'm wondering, is there a scatter method I can call on a data frame? Like if I do contlog dot scatter, no, okay. I have some scatter plots around here somewhere. How did I do this? With a for loop? I don't know if I want to bug with that right now. Same with the I think you use the same for loop, basically, yeah. Yeah, we're not gonna worry about that too much right now. So, that helps a little bit. We're gonna go back and look at our coursework. And so I've now log transformed everything, so that's gonna make it here we go. Log transformation can help reduce skewness when you have skewed data and help reduce variability of data. So in other words, it's gonna pull it towards like a normal distribution, which is one of your assumptions for linear regression, that the data is normally distributed. So I could, like, in theory, like run like the model again with the transform data and see what it does, but I don't feel like it's gonna make a huge difference right now. So I'm looking at currently, I don't know that you can see, I don't believe you can. Nah. You cannot see it. It's okay though. It's okay. So I have a few different scaling methods here. So I'm thinking I'm going to try mean normalization. Because that will put all the values between -1 and 1 and have a mean of 0. So I have like different features here that have like different, they're measured in different units of measurement. Like square footage is obviously like a geometric measurement, and like the age of the house is a measurement of time. There's no like such thing as like square footage in relationship to time or whatever. So doing like a mean normalization, I feel like should make that less of an issue. I just have to remember how to do mean normalization in Python. Okay, although our new variables don't look perfectly normal, there is clearly an improvement in terms of skewness. Now let's perform min-max scaling on acceleration standardization, log distribution, blah, 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 and mean normalization on log horse. Okay, so you're doing min-max scaling. I'm looking at this goal, like the lesson right now, to try to kind of refresh my mind. Acceleration. Where's acceleration? So it sounds like it's kind of, I don't know, I'm really tempted to just do like the same transformation for like every feature, but I feel like that's probably not the right way to do it. So what I'm gonna do is like one transformation technique at a time. I'm gonna go through. I'm gonna write down which features need to be transformed with that particular method. So I might actually do min-max scaling on everything. Because we have a lot of negative values in here too, which makes sense, but if we min-max scale everything, then yeah. So to do a min-max scale, we take a variable minus the minimum of that variable divided by the max of that variable minus the minimum of that variable. I need to write this formula down. So x complement equals x minus the minimum of x over the max of x minus the minimum of x. So I can plug that into a for loop. This way of scaling brings all values between 0 and 1. Bro. Man, I wish I would have taken a freaking calculus class in high school. This would make so much more sense now. What if I just did standardization? Yeah, that might be better because I don't necessarily know that I need everything to be between 0 and 1, but if I pulled the mean of every feature to 0, that would make the nature of its distribution more obvious. So x complement equals x minus x bar over sigma, little sigma, not the big sigma. Standardization. Okay, so how do I get like this just a standard deviation of a feature? I think I can do np dot, yeah, and I could do like cont log. Cool. Okay. And I know I can do the mean that same way. So for a feature in cont log dot columns, I want x bar equals np dot mean dot feet, and let's just see if that's like iterating through our for loop correctly first. So we'll just print x bar. Looks like it's gonna work. Nope. Spoke too soon. Cannot perform reduce with flexible type. I have no clue what that means. Cont log. Oops. Feet, 'cause I was just calling like that string name, not the actual feature itself. Cool. So I have my x bar declared, and now I need a sigma, which is np dot standard deviation cont log feet. That red squiggle in VS Code, like, it doesn't bother me in Microsoft Word, but in VS Code for some reason, like, it's just kind of like in your face. Like, I know it's not correct syntax yet because I'm not done writing the line of code. Like, leave me alone. So x complement equals, see, like, I know it's not, that's not correct. Like, please let me finish typing. Anyway, cont log feet minus x bar divided by sigma. I have no idea what data type this is going to return. Oh, why am I putting return on a for loop? Okay. What is this gonna do? Probably throw an error. Oh, cool. Whoops. I guess I could just create another data frame with the now standardized. I don't know if like I know how to do all these like transformations and normalizations and whatever, but I just like I don't feel confident in my understanding of like when to implement which one, which is upsetting to say the least. This is standardization. Yeah, we're gonna try mean normalization, I think, which is x complement equals x minus mean of x over the max of x minus the min of x. Okay. So I don't need sigma if I'm going to please don't. I know this. I know. Oh my god. Like, just let me use some filler text or not, or just like leave it blank. Like, I don't want the. There's probably a way to turn that off, and I just can't be bothered to deal with it right now. So we're gonna do mean normalization. So it's the feature minus x bar so x complement equals, Jesus Christ, I know it, cont log feet minus x bar divided by one of these days I'm going to learn all the sick keyboard shortcuts for VS Code, and I'm going to type like so fast. There we go. So I know this is going to normalize the means. think I can use PD. Do I concatenate it? I can just do this. Norm means feet equals. I realize that. I don't need you telling me. Can I do something about that right now? Oh my god. You know what? No, before I do anything else, I'm going to Google and I'm figuring out how to remove red squiggles. Press Command Shift Me to open the command palette, then type disable error squiggles. Thanks, Stack Overflow. That was not correct information. Everybody raves about Stack Overflow. I don't get it. Like, 99% of the time when I go there, like, I don't find useful information. Occasionally it comes in clutch, but very occasionally. Towards Data Science is a great website. Delft Stack's a great website. W3 Schools. So many better resources than Stack Overflow. Bro, you practically need a certification for VS Code alone just to, like, get it to work the way you want it to. Okay. There's no way that's... Yeah, okay. Please don't throw any... Oh my gosh, that's amazing. Okay. Norm means... word. So let's pass that into the histogram. Rectangle object has no property fig size. What? Oh. Fig sizzy. Fig size. That's one thing that I feel like would just put my VS Code performance through the ceiling, is if I could just get the tab autocomplete to work correctly. Okay, cool. So I'm pretty cool with that. We basically have the same shapes and distributions as the log transformed data. It's just everything's mean is at 0, which is good. Or it makes it easier to, like, read and interpret. It also makes me more questionable about, like, features like square foot basement, obviously, if we were to adjust for outliers, our mean would probably be closer here to like the central hump. But that's just so much data. I can't like we're either gonna have to throw that feature out entirely or keep it as is. We're probably gonna end up passing into the next regression model, and depending on the p-value and the variance inflation factor, we might throw it out. I'm kind of hoping that it has just like a stupid high variance inflation factor, and they'll give me a good excuse to throw it away. I'm just very like not psyched about getting rid of data, you know. It's kind of like cutting hair. You can get rid of it, you can't get it back. I guess you can technically get it back, but yeah. So that's cool. You know, I'm thinking we could also, just to get that visualization kind of, we could just run the same for loop for a few different transformations. So let's try like standardized and I keep like wondering, like, should I be including my categorical variables in this? Maybe. I don't know. Anyway. So we still need X bar. Now we need sigma. I feel like NumPy could have definitely picked a better abbreviation for standard deviation than STD. But they didn't ask my opinion. So X minus X bar over sigma. Oh, no, I didn't. Standardized. That's how you say that. Standardized. Typo almost got me again. What? Oh shit. Oh shit. Oh shit. Oh shit. I accidentally assigned those values to the wrong data frame. Whoops. Okay, this should work now. Mm-hmm. Mm-hmm. So again, this is pretty much like it, pulling everything to where its mean is at 0. But it's kind of giving it its own unique minimum and maximum values, which I kind of like. I'm getting very like, so you know I'm like thinking. Okay. So now let's try it. Let's just, yeah. There's no harm in doing that again for min-max scaling. Let's just make sure we keep fidelity with the correct data frame. I'm still going to complement out these visualizations because I feel like our actual like shape of our distributions isn't going to change much, which is good. That's probably what's supposed to happen. So that means that my code is doing what it's supposed to do. So I don't need sigma. And I don't need X bar here actually either. Okay. I have like my notes here in my lap because normally it's here where like my microphone and like stream stuff is. So I don't have the most ideal setup right now. It's just kind of my laptop, my phone, this microphone I just have. But I kind of enjoy doing this like streaming thing while I'm coding. So eventually we'll get a better setup. What was I doing? Oh yeah. Okay, so we're min-max scaling everything. We're just gonna delete all this. So we need to do min-max feet equals, don't do the red squiggles please. See, why is it doing it just for that spot and not like everywhere else? And like that doesn't bother me, but what? Dude, I need like a Udemy course on the S code. Okay. So our denominator, we have a denominator, denominator, and a numerator. Denominator, numerator. And our numerator is our feature minus the minimum of that feature. You know what? I'm going to declare that variable as x equals, because I'm tired of typing this out every dang time. Okay, so then we have x minus the minimum of x divided by the max of x minus the minimum of x. x minus min x over max x, right? Minus min x, okay. That's what x complement is. And yeah, we can just run that. And then we'll go min max dot hist. So I think I actually like this the best. Which I thought I wouldn't at first. But putting everything on a scale of 0 to 1. Which, because I have different units of measurements for these features, for some reason, I can't articulate why, but I feel like that is better for some reason. Okay. So all that work just to find out that, whoops, the min-max scaling is, as far as I can tell, my favorite scaling so far. And I'm going to, when you're working in a notebook like this, it's good to periodically kind of shut down your kernel and restart it and rerun all the cells. Because you want like ideally if this is on, it is on GitHub. You want somebody else that's never read or written or seen this notebook before to be able to like open it up and click run all and it go like top to bottom without any errors. Like you don't want like a variable called in cell 2 that's not declared until cell 5, and when you're kind of doodling, sometimes that happens. So rerunning your notebook and clearing your kernel will make that more obvious to you if you did do anything like that. And it makes it easier for other people that have not seen it before to kind of follow along. And sometimes you'll get like multiple values assigned to the same variable because like maybe you renamed something or something, or you'll have like one value that's assigned to multiple variable names, and like all kinds of weird stuff. Like you'll have like different values that are assigned to different variables that are assigned keeps all that kind of clean and copacetic, so to speak. So that's for transforming all my continuous variables. I don't think you're supposed to do this sort of thing for categorical variables, but I don't know that for sure. So I think what I'm going to do now is I'm going to I want to run another regression model, but I also want to figure out what's going on with hot cats. As far as like, does it need any transformations? Am I supposed to transform categorical variables? I don't know. I do not know. What I do know is that I am going to take a break from the coding real quick, and oh good, we ran everything. And I'm going to share this stream to my Facebook. Just to let my friends know I'm doing this. Oof. Oh no. I open Facebook and the first thing I see is a family member having a family emergency. Not emergency, but somebody's a little ill. Come hang out with me on my YouTube live. I don't know. I have like 4 different camera lenses on my phone. And I don't know which one to look at. Hopefully you can't tell the difference. Yo, what is going on with my cursor? What the heck? I gotta get a beefier rig or machine, because it does not like doing YouTube and Facebook and streaming and coding all at the same time. I've said that every single stream I've done now, so should maybe look into it. Come hang out with me on my YouTube live stream. While I currently linear has too much words. How do I word this? Huh. I wonder if that link actually works. The stream URL should be where I can like share it, right? That's enough Facebook for one day or a lifetime. All right, so log transformed the data that needed it, min-max scaled everything. I'm going to look at if my one hot encoded categorical data needs any kind of transformation. At this point, I don't think it will. I don't think that's how that works. Yeah, I'm just going to investigate that data frame momentarily. And then we're probably going to concat it with the transformed continuous data. Can I make a histogram out of this? I don't know why. I always get anxious when I'm like doing things when I'm programming that I'm not like sure about. But it's like it's just gonna throw an error. But I feel like scared. Like But yeah. Worst case scenario, so it throws an error. Yep. Called it. Let's see what the error was. Oh my god. It wasn't even the data. It was me doing my Fig Sizzy again. Fig Sizzy. I'm wondering if Pandas is gonna like, based on those prefixes, like when it one hot encoded it the first time, it's gonna know to like put it all together. I don't think this is gonna work. I think it's stuck in a while loop or something. My computer does run a little bit slower when I'm like streaming while I'm doing this, but yeah. That's what I thought. Because everything's either 0 or 1, so it's gonna be bimodal. There's no point in like visualizing it on a histogram. Okay. That's what my intuition was. Now that I'm seeing it, I'm like, yeah, makes sense. Because everything's mean's gonna be like some decimal number. Okay. So, I think what we're gonna do now is we are going to concatenate everything together. So pd.concat, and we're going to concatenate min-max with hotcats. And oh yeah. So the first positional argument is your data frames, and then I think, do I have to pass an axis here? Yeah, I think I do, to let it know that I'm concatenating by columns and not rows. Yeah, and then we're gonna do transcoded dot head just to make sure the data frame's looking all good. Cool. We don't need that anymore. So now I'm gonna scroll on back up here, and I'm just gonna copy and paste the code that I used for the first linear regression model. Let's get that out of the way. transcoded here, not x. Y is still the same thing. Right? Yeah. Let's run that model. Okay. So our R squared value is the same. We have a few features with p-values that are worth throwing out. Okay, I see what's going on. So probably should not have dropped. Huh. So the problem is that this stats models isn't understanding. Oh my god. That like these, for example, are all the same variable. So it makes sense that just this segment or subset of bedrooms would not be statistically significant. Obviously, you need like the whole feature. So this is not a math problem, this is a coding problem. So when I pass it into this model, yeah, I concatenated all of the predictors with hot cats and then dropped. I did drop it and it still understood what was going on. I'm going to see if not running this line of code would make a difference in our model. Doesn't look like it does. So big X is just our predictors. It's like everything besides price, but like the raw data. So I concatenated hot cats to that, and it worked fine here. So how come that's not the case down here? because it's an attribute, not a method. At some point, I think I dropped the respective original columns that go like with the one hot encoded ones. But where? That's where. So this is another great example of why you want everything to be able to run top to bottom. Because now what I'm thinking is this should at least partially fix what's going on. It's not going to, unfortunately, log transform this stuff. I don't know why this can't be put into a for loop either. I think I was being dumb. But we're going to... Like, I don't know why this can't be all in a for loop the same way the, like, other transformations were. Or scalings were. Whoops. Wrong window. I'm just kind of perusing my notes while I wait for the notebook to run. It's probably already done running, but... Oh, it's not? Okay. Woo! Gonna be patient. See, this is one of the nice things about streaming too, is that I use my phone for the webcam. So when I'm doing this, like, I can't just like start scrolling through TikTok or whatever and then kill 45 minutes accidentally. Accidentally. This is taking an eternity, so okay. I was worried that there was like some cell that was getting kind of stuck. I'm probably going to comment out these visualizations just because every time I do this, they take an eternity to run. Like you can see, this one took like 36 seconds. It's 36 seconds of my life that I'll never get back. Just waiting on a stinking scatter plot. Or scatter matrix, whatever. Yeah, we're gonna go ahead and comment out because I'm not really like using these visualizations anymore. Yeah, okay, so back to the original question. Can I put this into a for loop? I think so, because now there's like a few lines of code here that need to be here that aren't. So I'm going to use that same variable name for the data frame, but I'm going to go for feature in contlog.columns wait, no, not contlog, because it has no columns. Whatever that list was, const. Probably shouldn't be named const. It's not very idiomatic, but we're just gonna roll with it for now. That's also not a data frame, so. Okay, what data frame am I calling this on? Xconst, okay. Xconst.columns. I feel like columns should be purple. Okay, that's working. I need contlog feet to equal np.log x feet. And we'll still need all the weird stuff because that's like a feature to feature basis. All this right here. Of course, we might have more now that we need to deal with. Let's run that jump. Oh, sick. Let's double check this before we just delete this whole cell, but I think we're gonna be able to get rid of like all this junk right here. Okay. Okay, cool. floor's condition and grade should not be in here. Because they're categorical variables. Relative living space and lot size look like they're categorical, but I know that they're not. So that's interesting. I really like those variables because I came up with them. They're those features, but we might have to end up throwing them out. And then bedrooms and bathrooms are also shouldn't be in here. But that was the issue from earlier. I was thinking about taking a walk, but it's dark outside. I might go for a walk anyway. So let me look at like min-max. And X. Starting to confuse myself. So floors, condition, grade, bedrooms, and bathrooms are all categorical variables, so they should not occur in like the log transformations or anything like that. I do know that the log transformation is working in the for loop though, so we can just delete this whole cell actually. So this is all coming from const. Which that was a typo, as meaning to do like cont, as in like continuous. So now I'm remembering why I removed all this stuff. Got to redeclare min-max. So this is good. We have all our continuous variables. And they've all been log transformed and scaled, min-max scaled. So I still don't, I guess, really understand y. Oh shit. Excuse me. So that's basically means this is a pretty weak model. So I've been having this issue all along. I was just passing the wrong data into the original regression model. So there's something I'm not understanding about one-hot encoding, or specifically how to pass one-hot encoded data into stats models. Okay. So I'm probably going to be on this other window here for a second, so I'm going to show you guys this. I hope this isn't like an ethical thing with Flatiron. I'm not like giving you guys the PDFs of stuff or anything. So in one of these modules there was something about dealing with categorical variables. Okay. We're gonna get rid of all this junk here. Well, maybe we need that. I might need to look at it. I can also go and look at the lab. Okay. But that didn't really explain to me at all. What about the HTML. I'm a data scientist, not a web developer. How to pass one hot encoded data into stats models OLS. How to fit a statistical model with a one hot encoded variable. Great, Stack Overflow. Then I ran mixed effects regression, which worked fine, blah, blah, blah. I don't know what mixed effects regression is. This doesn't even have any answers, it just has the question. Chalk another up. Another L up for Stack Overflow. Towards data science. I just mentioned earlier how this is a great website. Are you gonna load or what? There we go. I've been sitting in this chair too long. I'm getting very unrestful. Okay. Bro, I don't want to know about this stuff. I want to see some code. I know about the dummy variable trap. Oh my god, okay. Okay. What is this? Oh, I remember what that is. I have the cheapest boom mic or boom stand ever, and I literally have like a mug upside down propping it up so it doesn't like keep falling. That's not the error that I'm not getting an error. I just, okay. So what I said that I thought I understood about pandas and stats models at the beginning of the video was wrong. It's interesting though. that like the fact that it has like a third or 3.5 floors, whatever 3.5 floors is, that might be like an outside balcony or something. I don't know. Is not statistically significant. But if it has 1.5 or 2 stories, is statistically significant. That's just barely statistically significant. So, wow. I think our skewness actually got worse now. Oh my god. But our R squared value got better. So let's run a VIF on model data. That was like the error originally, as I was passing in the original data, big X, instead of the model data, which was the concatenated data, which is what was making me think that stats models was understanding the dummy variables correctly. But it was not. It was me making pretty critical oversight. I'm probably not going to keep this stream up much longer. I'm starting to lose steam. It's time for some dinner, a walk, a workout. I'll get back to it later. So our variance, we have a lot more variance inflation factors that are like way closer to the acceptable ranges now, which that's good. And that was just the difference in me passing in the correct data for the model. This is all correct. Okay. So I think I'm gonna have to just drop some of those columns, those one hot encoded columns, um, and like I'm just gonna probably do that based off the p-value because they all have like an infinite variance inflation factor. So yeah, I'm just gonna go back and look at all their p-values, and I'm gonna take notes on which ones are above 0.05. So like grade 7, for example, but not grade 6 for some, or 4 or 5 for some reason, but still grade 3. Nearly grade 3 actually. I'm gonna drop any of these that are not statistically significant according to the p-value. And I'm going to, I just lost it. That makes sense. Yeah, so I'm going to drop the statistically insignificant one hot encoded columns, I'm going to drop, I should probably write this down. Way down here. Oh my god. Okay. Drop insignificant one hot encoded columns. I need to drop categorical columns entirely since they are represented with the one hots. I'm going to do all that to the initial data, the model data, and then I will run the transformations on that data and see how the new regression model turns out. I'm thinking about dropping condition like just entirely, not even one hot encoding it or anything, because condition and grade represent essentially the same thing. Grade is just a little bit more granular, and in the original data dictionary it's a little bit more specific. So grade actually refers to like if the house is up to code or not, and like that sort of thing, versus grade is just, or condition is a little bit more like like is it nice or not, or at least that's what the available information sort of says. So I think I'll do that. I might even just completely drop bedrooms and bathrooms, like not one hot encode them at all, because that data is more or less represented with bed bath ratio, and that was essentially, I did essentially the same thing with year. Like I dropped a year, like the year it was built. It should be around here somewhere, or no, not anymore, because I have the age of the house right here, which is essentially the same information, right? Like the year it's built and how old the house is the same information. So I might just apply that same rationale to the bedrooms and bathrooms since I have this right here. Yeah, I'm just gonna have to kind of rethink how I'm engineering the data, from like an organizational kind of standpoint, just like trim some fat, so to speak, and get back to it. So my microphone's not quite picking everything up. So yeah, I'm gonna do that, and I'm really enjoying doing these live streams. There's not, where the heck is, I don't have my deal. Oh, y'all are still looking at Google right now. My bad. Whoops. I've been looking at my notebook for the past, I don't know how long. And I've just been looking at Google. I am so sorry. Like I said, I am new to this like streaming thing, so I'll figure it out. But it's really fun. I think it's good for me to sort of hear my thoughts and ideas and things out loud. It definitely keeps me off my phone while I'm trying to do work. So I might make this a little bit more regular of a thing. And Yeah. Yeah. All right. Well, I believe that's it for the stream today. Yeah, we're right about 2 hours. I'll do it again tomorrow. I figure I would do this every day, so for probably 6 or 7 hours. So might as well do it. I think like a couple hours a day, an hour a day, maybe. I'll just do like a daily study stream thing. Yeah. So till next time. All right. That's it.